Hello everyone, I welcome aboard to my second video on software defined access, where we are going to go a deep dive on data traffic component. In my video 1, that was the part 1, where I have spoken on DNAC, hardware and the control plane, policy plane and the management plane component like Epic EM and Cisco IS, and as well as assurance and analytics on a deep dive, roles and responsibility. So this video will be mainly focusing on data traffic component, right? So the following would be the agenda of overall the presentation, or the overall the discussion would be what is the software defined access components with respect to data traffic, like fabric edge, control plane, fabric border, WLCs or access point, along with some prominent use cases where exactly SDA can give you a benefit to an enterprise customer, right? And lastly, I would be requesting as a thank you to wrap up this session. So without wasting time, let's jump on to deep dive theoretical concept on software defined access with respect to data traffic components. So I'll start with control node. Software defined access control node. So fabric control plane node is based on LISP map server / resolver concept, Lisp. So Lisp is nothing but a locator ID separation protocol, which is there from almost 5 years or 6 years, which is a very simplest concept and which actually helps you to identify your endpoints, where exactly they are sitting, and create an overlay between the endpoint to endpoint based on the request, right? So it normally helps, or it runs the fabric endpoint ID database to provide an overlay reachability. So as I said, SDA is a concept which is not an underlay concept, it's an overlay concept. So Lisp helps to build an overlay between point A to point B communication. Another important point for Lisp is it is one of an core and key component. You can say as a central SDN controller, which has the overall database of your fabric endpoints along with their endpoint to IP mapping and where exactly those endpoints are located. So you can see the master database in the overall system. Also, control plane supports multiple types of endpoints. I mean, multiple types of endpoint ID lookups. You can say like IPv4/32, IPv6/128, or a MAC address. Make sense? So few are silent features which I'm going to highlight, which I already said just a couple of seconds back. Like I said, it's based on Lisp map server and resolver, right, which actually has a tracking database to provide an overlay reachability, and it receives prefix from different fabric edge nodes for wired and as well as for wireless from your fabric WLCs reachability, right? So it has a database for both, and it also gives you a simple host database lookup that endpoints on the edge node wherever they are residing resolve the lookup and request from your remote edges. So it resolves the lookup request from your remote edges nodes to locate the endpoint. That is what the third point is mainly. So you can consider as if like that if someone is actually requesting where I need to connect to point B, if it is not there in the local database cache of the fabric edge node, it will request to your control plane and it resolves that particular endpoint and it gives the destination edge node IP address behind which fabric edge it is actually connected, right? And it frequently updates the fabric edge nodes and the border nodes with wireless client mobility, so that along with the router location information, so that the seamless host mobility happens in the overall campus fabric. Make sense? So this is what the pure basic concept. So if you understand all these points, so you understand the control plane roles, or what exactly the importance in your SDA architecture and what exactly it's playing a key role, which it is actually playing a key role because it is actually giving you an information of what all the endpoints are there in SDA and where exactly they are located. Okay, so going to the next one, another key one is a border node. Border node in SDA, as a name suggests, border. Anyone who is going to enter into your domain or going out of the domain, border node are the key guys. I mean, entering with respect to purely on data traffic. So simple state of saying is all traffic entering or leaving the fabric goes through these fabric borders, right? And another important key thing to know about border node is there are two types of fabric borders. One is a border and another one is a default border. So what do you mean by that? Right? Both the types provides actually the fundamental routings. I mean how to reachability of different prefixes across your domain to other domain. I mean entry to exit points for all data traffic going into or out to a fabric overlay. Make sense? And as well as apart from routing, as well as virtual network information and as well as policy enforcement outside the fabric. So fabric border, as I said, two types, right? The one is border, so that means fabric border is used as a main function for known IP prefix. What do you mean by that? Consider in traditional network, it is as if like an MPLS router where you have a known IP subnets from different branch location, your data center routes only, right? So that it actually advertises those particular subnet to your fabric edge nodes. Makes sense? Default border, as a name suggests, default border, it is anything which is not known IP subnet go to this particular default border router as a default route in our traditional network. So I mean traffic going to your internet or a local breakout, right? The border is where the fabric and a non-fabric domains exchanges endpoint reachability and policy information. Make sense? So it is the border between your SDA based or SDA speaking language devices and non-SDA speaking language devices. It's very simple layman definition of a border route. So few silent features. As I said, I mean most of the things I've already told. So just articulating on the presentation. As I said, it's mainly of an Lisp proxy tunnel router (PXTR). Don't worry about this terminology because I have another video on Lisp where I'm going to clear out this particular terminologies of Lisp so that you can easily map this video along with that video to get more clarity if you don't get a clarity with this particular video series. Make sense? So as I said, it connects the NL3 network from different fabric to your local domain and exchanges endpoint reachability and policy information, and as well as responsible for translation of your WRF and SGT from one domain to another. Right? Key important point, border node is a node between your SDA speaking devices and non-SDA speaking devices and helps to communicate a flawless communication between the two entities, right? As well as responsible for translation of VRF and SGT from one domain to another. Make sense? VRF to SGT, VRF and SGT from your SDA speaking devices to non-SDA speaking devices. Another key important aspect or a key important team member in SDA architecture. Yeah. So let's move on to the next one. So we have seen border node and we have seen control plane nodes. So next another key component is edge nodes. So software defined access also consists of edge nodes. What do you mean by edge node? Edge node is nothing but wherever your endpoints are directly connected to your fabric, right? I mean endpoints which are wired. We are speaking about the wired edge nodes here. So what they mean, I mean any device or anything which is connected to your fabric enabled edge nodes are actually the entry point to into your campus fabric inside your domain, right? So what it actually helps, it actually are the responsible for identifying an authentication of wired endpoints because it's a fabric edge node, and already we have seen in our video one that IC is also integrated. So you can enforce those policies on these particular switches ports that someone is connecting with certain laptop or certain devices, what policies it should be enforced on that particular port and what VN it should be allowed, right? So as I said, with respect to your Lisp concept, these are your Lisp tunnel routers. So fabric edge nodes, comparison to your Lisp terminology, it's a tunnel router. I mean, it is playing a tunnel router functionality in your SDA architecture, right? And main responsible for authentication of endpoint wherever they are moving around, right? So as well as it registered the wireless IPv4 IPv6 endpoint ID information with your control plane nodes. I mean definitely anything which is getting plugged onto this fabric edge node, it will be registered to your control plane node. And another key thing with respect to the host mobility in your SDA architecture is it provides an Anycast L3 gateway. So And host, if it is connected to your switch A or switch 1 of your SDA architecture, if it moves from switch 1 to switch 2, you don't need to worry about the gateway because it's an Anycast L3 gateway. So it's responsibility to provide an L3 gateway for your connected endpoints, right? And it provides in virtual network services for your wired and wireless client. Also, it helps to onboard your access points into Fabric and form a VXLAN tunnels with your APs. We are going to see that in our next slide actually, what exactly I'm speaking on that. And apart from other few functionalities, if you think from edge device point of view, it provides a guest functionality for wireless host. I mean, it interact with your guest border. I mean, if you're going to design something as a separate entity like guest border or guest control plane node, so those things can also be done, right? And as I said, it is more of a registration of endpoints information to control plane node. Whenever any device or any host connect to your edge node, it will be firing an information to your control plane node. Provides an L3 Anycast gateway, and it mainly encapsulate and decapsulate the host traffic to and from your endpoint to your connected fabric. So the key role for the fabric edge node is more often from your laptop or endpoint, which are actually communicating on your SDA fabric overlay. Okay, so I hope the three components which I have spoken so far, you are clear with the definition of roles and responsibilities, and you can clear out your more concept when we are going to speak on the traffic flow with wired and wireless network, and as well as with the Lisp concept, like what is by location ID separation protocol with their functions and role, right? So next on the chart is Fabric WLCs and APs. Fabric WLCs and APs, for it is purely for your wireless client. So what I'm saying here is, so as I said, software defined access Fabric WLC. In this particular concept of WLC, in Fabric WLC, I would like to say, the control plane is still centralized at the WLC for all wireless functions, right? So what all those wireless function, it is still responsible, like for AP image or config, radio resource management, client session management, and roaming, and all other wireless control function are still with the Fabric mode WLC, right? So apart from that, like the control plane, as I said, the cap app tunnel is still being leveraged from your all access point to your WLC over the top concept. I mean, Fabric has become just a transport layer, right? So you can see a few silent features. Like I said, it's a centralized control plane management and a distributed data plane, which would be distributed because of the nature of the architecture of software defined access. And WLC also communicate with your Lisp database, host tracking database, you can say, for your control plane communication, right? So that is also one of the key important factor. Apart from few things, for wireless, client MAC address are being leveraged for endpoint ID, right? But in wired, we are saying that it's an IP address, and as well as to edge node behind which particular switch it is located, and it keep on tracking or interact with your host tracking database on control plane node for your client MAC address registration with whatever the secure group tagging or virtual network information it has, right? Because the virtual network information is mapped to a VLAN, right? So that's why. And WLC is responsible for your updating the database with roaming information for wireless client, because it has a control plane communication directly. So control plane is not coming in that particular overall flow. So all APs are connected with your cap app tunnel with your WLCs, and WLCs gets the overall information of a wireless client roaming and mobility, and it updates your control plane nodes. Make sense? Fabric enabled WLC, it has to be physically located on the same site where the APs are there, because the initial release doesn't support AP to be deployed across your WAN from WLC. Maybe in few or further future release, it would be over the WAN also. Make sense? Another key important thing, if you are designing or if you are going for an integration, make sure that you are actually within 20 milliseconds of latency between your WLCs and AP, and usually the same site. That is why I was saying in my previous point. Okay. So next come is actually the Fabric mode APs, right? They are actually the extended, or they can say extended data plane in SD access for wireless edge, right? So if you see that fabric mode APs, which I already shown in my previous slide within fabric edge, it actually connects with the edge switch. So fabric AP is a local mode AP, number one, and it need to be directly connected with your fabric edge switch, so that the cap app control plane goes to the WLC using fabric as a transport. I said right, with this wireless architecture in SDA, control plane is still leverage between the APs and WLC over this fabric transport or over this fabric SS switch, right? So fabric is enabled per SSID. So for fabric enabled SSID, normally what happens is access point converts the 802.111 traffic to 802.3 and encapsulate into a VXLAN header with the VNI and SGT information of the client. Very key important concept, you need to understand that any wireless client, so what this access point used to do, they used to take the feed from the laptop as an data traffic. I mean, definitely that would not have any VLAN or anything else. So once it is connected to your access point, it converts that into a from wireless header of 802.11 traffic to an 802.3 header and encapsulate into an VXLAN by adding the SGT and VNI information of the client, right? Then AP forwards the client traffic based on the forwarding table, whatever been programmed by WLC. So you can understand the standard traditional wireless, a local switching or centralized switching. If anyone wants to go to communicate to your other SSID or default route, it goes to your WLCs and where the switching or routing happens, right? Same thing happens here. And usually VXLAN tunnel destination is the first off switch. That's why I said that in our fabric edge switch, where I explained the rules and responsibility of that particular switch, it actually terminating the AP to edge switch as a VXLAN tunnel as a first hop. Make sense? So SGTs and VRF based policies for any wireless users on fabric SSID are applied at the fabric edge, the first immediate switch. Now you understand the concept, right? So hope things are getting cleared, whatever the way I'm trying to articulating the roles and responsibility of each and every component, right? Same as for wired. For fabric enabled SSID, the user data plane is distributed at the AP, leveraging the VXLAN as an encapsulation, right? So access point applies all wireless specific features like SSID policies or AVCs or QoS, etc. So with this, what I'm saying is fabric mode APs are a bit intelligent compared to your traditional APs. They are connected or they used to create a VXLAN tunnel with their immediate first off switch for the data plane traffic traverse from AP till your other node wherever the destination is. But another key important aspect in wireless architecture for SDA is control plane, the cap app tunnel is still actually going as a standard way of format from your AP to WLC, leveraging this particular fabric as a transport, which is called OTT, over the transport, right? So all the policies and the information about the wireless client, which are being leveraged with respect with the help of your MAC address as an endpoint in your control plane node, by having a direct connectivity from your fabric mode WLC to a control plane node, so that you have the complete end-to or complete host database tracking information for your wireless clients. So all these are the key component with respect to movement of your host, either it's a wired or wireless, and the key control plane component, control plane nodes and the fabric border for exit or entry are playing a key role. So I have tried to give an explanation with respect to the concept of it, like what these particular devices are helping out in SDA world or maybe SDA architecture world, I would like to say, right? So if you understand this particular point, what I said, and try to draw a logical diagram in your mind, definitely your concept will be clear. But definitely I'm going to release few videos on traffic flow, which will be very helpful for you to understand that particular traffic flow in depth if you have gone through this particular video for more clarity of the concept. Make sense? So with this, I'm going to jump on to the next slide, which is mainly for our pre-sales or solutioning folks, where exactly the use case or the prominent use case, what exactly software defined access is helping to our enterprise world, right? So what are the prominent use case? Like it helps for enhanced automation, right? If I say automation, I mean it's more from your combination of multiple tools in your Epic EM is integrated with your DNAC, and automation of policy getting pushed onto your endpoint host, and multiple tools are being embedded into a single dashboard by giving you a zero touch provisioning of your underlay network. You're not configuring any VXLAN, that's an automation. You're not configuring any devices, that's an automation. A single click or the policing done from your dashboard, so which is saving a lot of time. You're not configuring each and every device, please make sure. So that is also a key for an automation. You're designing from a single dashboard, and with just a click of your logical design and provisioning on all those particular profiles, and the overall particular configuration or template is been pushed from a single device or single entity called DNAC. So that's an power of automation, right? Simplicity, or you can say simple and scalable, right? Simple and scalable in terms of it is scalable architecture. You just connect the device, and the role is, if it is fabric enabled stuff, it will be part of your device. You don't need to worry about your underlay architecture or any spanning tree loops or L2 switch if you connect any switches onto your traditional world where you are afraid of a looping concept. It's pure L3, scalable because of the routing architecture. So it's just an IP routing or prefixes between your underlay for edge device connectivity and an overlay for endpoint connectivity from your control plane point of view, right? Because of an overlay concept, it's simple and scalable. Makes sense? The next key one is an advanced secure architecture. So secure. So you can see secure in terms of micro segmentation and macro segmentation. We are doing two level of security or segmentation in SDA. One is a macro level segmentation, right? Macro in the sense that we are creating different VNs, virtual networks. Virtual network is equivalent to an VRF in our traditional world. So in VRF itself also you can have multiple groups, right? You can have multiple groups which are common with some your AD policies. You can have one user or one group can talk to another user of another group with certain policies. That is called micro segmentation. So you have flexibility of securing your overall network with whatever the way you want to do. Make sense? The fourth is an intuitive network. SDA is an step, or it's an actual start for an intuitive based network. As I said in my start of the video of intent based networking, because of the deep dive analytics or because of the assurance platform which is embedded, you are actually giving help or predicting the solutions also if there is any problem in the network with the help of assurance and telemetric analysis. So that's why it's intuitive. So you don't need to worry that what exactly the thing is happening. It is being helped by the overall system, and it's given as an intelligent way to end user that things are getting worse, so some problem here, and you also follow certain steps to overcome those particular issue. That's why it says intuitive network. And the final key is it's a borderless network. Gone are the days where you need to configure each and every switch with your VLANs and access list or policying or route maps onto each and every switch to make it a more cumbersome concept. With SDA architecture, with integration of eyes and analytics and doing an configuration provisioning from a single dashboard, right? And with an overlay architecture, control plane separate, policy plane separate, you are creating a policy per host basis. What does that means? You are not at all binded with any VLAN, IP, or any per switch based concept. So whatever the policy has been allotted to your endpoint host, or either it's a wired or wireless, the policies are being moved across the fabric, irrespective you are at switch 1 at 11 o'clock or switch 5 at 12 o'clock. That is means borderless network. So you don't need any border or any segmentation. What we do in our traditional world, configuring VLANs, IP accesses and stuff, everything is seamless with a high level of advancement. I hope these are the prominent use cases which will help you to defend when you are speaking about SDA in any wider presentation or you're explaining any solutioning. With this, I would like to say thank you and keep watching and for all these video series, and subscribe for this particular video for more talks and updates, and which will be helping me also to rectify or to add more improvement in my upcoming series. So stay tuned for further videos which will be more coming on in-depth concept of Lisp and traffic flow in wired and wireless with respect to SDA, and as well as different detailed function of border routers in my upcoming series as committed on second week of every Wednesday. Thank you very much.